Today, let's talk about moment of inertia. Before we talk about moment of inertia, let's talk about mass first. If there are two objects have different mass, one is 50 kg and one is 20 kg, which one you think is harder to move? The answer is obvious. The heavy one is harder to move. Same idea for the moment of inertia. The one with higher moment of inertia is harder to rotate. Let's see an example. If there are two people on the merry-go-round, which one made it harder to spin if they have the same mass? The one on the center or the one on the edge? Based on the moment of inertia equation of the disk, which is I equal to mr squared, so the one that outside will make the merry-go-round harder to spin because you have higher r, so you have higher moment of inertia. Let's see another example of moment of inertia. A person that works on the tightrope. It is more than just balancing on the rope. You have actually moment of inertia involved. By holding a long rod, you increase your moment of inertia. Moment of inertia formula for a rod is I equal to 1/12 ml squared, where m is the mass, l is the length of the rod. By holding that rod, you are increasing the mass distribution, which you are increasing L, make your moment of inertia higher. By increasing the moment of inertia, it makes the person harder to rotate. Let's see an example of me walking on a not a tightrope, but on a really narrow wood. As you can see, I will walk on the wood, try to adjust myself, not falling off from that wood with the rod. I can walk more stable, and whenever I move or tilt it to the side, it doesn't matter. In other angle, you can see my whole body is waving around, trying to find a good position to walk, having a hard time. But with the rod, I walk more stable. You can see I tilt, but it doesn't affect that much. Whenever I tilt to the side, the rod will adjust for me.